In this video, we are discussing the proposed mechanism for MOT1 mediated displacement of TBP from DNA. This project was done by Jessica, Josh, Kristen, and Taylor. This proposed mechanism is based on the structure of MOT1 bound to TBP from the E. caniculi organism. Our first character is free DNA. Our next character is MOT1, which is a swift-SNF enzyme that displaces TBP from the promoter DNA and regulates transcription. It has a latch, which reduces DNA binding and TBP dimerization. It binds to the DNA binding groove of TBP, acting as a chaperone. The final part of MOT1 is the heat repeats, which play a role in recognizing the convex protein interaction surface of TBP. Our final character is TBP, which is a general transcription factor that binds to the TATA box of DNA to allow for recognition for transcription. The first thing that happens is the binding of TBP to the TATA box on the DNA strand. The TATA box is found 30 base pairs upstream of the TIS. It binds to the minor groove of DNA. This binding occurs through hydrophobic interaction of TBP's binding groove, resulting in a conformational change of the DNA strand as it becomes a 90-degree angle with itself. Now that TBP is bound to DNA, MOT1 is brought into the picture. MOT1's acidic loops of heat repeats 4 through 6 bind to the positively charged TBP surface at H1 and H2. The upstream minor groove of DNA also is interacting with the swift-SNF domain. With these interactions, groove tracking begins by the swift-SNF disrupting the TBP-TATA interaction through either pushing or pulling of the TBP, resulting in translocation. Now that the TBP is displaced from DNA, the latch binds to the exposed hydrophobic groove of TBP, which blocks future binding of DNA. The latch's role in the MOT1 complex gives this protein an ability to act as a TBP chaperone and controls its interactions with other macromolecules. Once the latch has been bound to TBP's DNA binding groove, MOT1 dissociates from the DNA, promoting the release of free DNA from TBP. This mechanism shows how strong the affinity of TBP to DNA is and the regulatory role that MOT1 plays in transcription.